So now let's integrate using our inverse trigonometric functions. So we established that the derivative of arc sine x on A looked like this, and the derivative of arc cos looked like this, and the derivative of arc tan looked like this. That means we can go the other way. The integral of something that looks like this is arc sine, and the integral of something that looks like this, basically the same but with a negative on top, is arc cos, and the integral of something that looks like this is arc tan. Now, these are only defined in certain situations for A. These ones in particular are only true when A is positive. Well, actually, it's got even more restrictions than that. A has to be greater than x, otherwise I've got a negative number under here. So there are some interesting restrictions here. But if I go by those restrictions, this happens to match this. And the same for cos. And here, A can't be 0 because then I'd be integrating 0 and it wouldn't make any sense. In fact, I'd be dividing by 0, so I certainly can't have A equal to 0. Well, you might say, this is pretty useless. I'm learning some integrals for some very bizarre looking rules that are never going to happen in practice. Except they do. And the reason is, these are actually Pythagorean kind of relationships, so they turn up surprisingly often in real-world modelling. Now, of course, this being specialist maths, we're not that interested in real-world modelling, but we are trying to teach you some mathematical techniques that you can use anywhere else for some real-world modelling. So, for example, if you want to integrate this, you would say, well, there's a negative on the top, and 9 is 3 squared, so I'm looking for arc cos of x on 3 plus a constant. Alternatively, it's exactly the same, put the negative outside the front, and it's negative arc sine of x on 3 plus a constant. Be careful, the constant you get in either case might not be the same. It depends very much on your initial conditions.